It's my pleasure to introduce now Benoit Sagot from Inria, Paris. Benoit is a senior, even though he doesn't look too senior to me, but he's a senior research director at Inria Paris. He holds a Prairie chair, so we had a presentation by Prairie this morning. Benoit is one of the lucky chair of Prairie, and he has a lot of contribution in the field of natural language processing. So, Benoit.
Thank you, François, for a bit too nice an introduction. I'll be actually talking about some of the results we have been obtaining in my team at Inria, and most of them in the context of my chair in the Prairie Institute. It will actually be somehow a follow-up or a complement to some things that François has been describing and discussing, since I will also speak about language models, large-scale language models, but more from the point of view of the data on which they are trained. So as François said earlier, these large language models are trained on huge amounts of text data, which inevitably raises the question of how we can actually get access to such large amounts of data. Which features, which properties such amounts of data should have, and how we should prepare or pre-process these large quantities of textual data before we can actually feed them to a neural architecture to train a large language model. So I will be sketching a few results and a few experiments on these subjects. Keeping in mind and actually discussing a little bit more some of the issues and limitations that are associated with language models. Once again, from the point of view of these training data on which they are trained. So the first thing, back in 2018 or 2019, large language models were something new. And we realized that, in fact, if we wanted to have a language model, for a large-scale language model for French, we actually needed the training data to train one. And we realized, actually, there was not any sufficiently large training corpus available for French, despite French being obviously a very well-resourced language. And we decided to begin the development of a very large corpus for French. Now, in doing so, we decided to go for a completely freely available corpus, and therefore to base our corpus on web-based data. And we immediately realized that if we do this for French, there is absolutely no reason why we wouldn't do it for other languages as well. And this was the reason, and the beginning of the OSCA project, which I will be describing very briefly. So, again, in order to train the language models we have been discussing today, you need a lot of data, and you can find this data in basically two types of sources. Firstly, non-freely available data, or non-freely accessible data. It isn't clear whether it's completely legal to train and then distribute language models on such data, especially if the data has not been retrieved completely legally. Think of some of the corpora based on books or newspapers or scientific papers or books that you can actually download on the internet if you know how to do that. And again, we think that's not the right way to go, and we decided to actually use web-based data. And there are two basic ways to actually get access to a lot of web-based data. Either you develop your browser yourself, your crawler yourself, or you actually rely on an organization that does it for you, because that's what they do, and it's called Common Crawl. On a very regular basis, every other month or so, Common Crawl make public a partial dump of the internet, which has the feature of not being language classified. At least back then, it was not classified by language. And still today, it is arguably not the best language classifier that they are using. So basically what you get is an enormous quantity of data, that is not filtered. It does not contain only language data. It contains also noise and all sorts of non-linguistic content. And it is not classified by language. So you have to do something to actually extract, for instance, the French data. And so this is what we decided to do. Again, we wanted to, so as a result, we wanted to develop a very efficient pipeline because these dumps are extremely large. An efficient pipeline to actually filter and classify by language this data. We have been distributing a number of versions of this OSCAR corpus since then. You can download it anytime. And these corpora make it actually possible to pre-train or to train language models for over 155 languages. So basically, the first version of OSCAR was published in 2019. It allowed us to develop a number of language models. CamemBERT, the first large-scale language model for a language other than English, and indeed the first for French, about which I will say a few words in a few minutes. ELMO models for a number of languages, a French ELMO as well, and other teams have actually been using OSCAR for quite a while now, and for instance, to develop and train many language models. Since then, we have improved OSCAR. We have a faster pipeline, completely rewritten in Rust. We are adding more and more metadata in the corpus. So for instance, we try to identify automatically at least some of the content that is arguably offensive. We do not remove it because we think there are applications and use cases where you actually need to have this offensive content or pornographic content, but having labels allows you, if you want to do that, to actually remove such content. And one of the latest things we have achieved, and it is included in the latest version of the corpus, is that we do language identification at the document level, not at the sentence level, which allows us to actually improve the quality of the language identification. And of course, the first version of OSCAR was trained in 2018, 2019, was extracted in 2018, 2019. That is before COVID, before Brexit. And it was important for us to actually update OSCAR with newer dumps from Common Crawl so that at least the language models trained on the corpus are aware of these events that are more recent than the first version. So just to give you an order of magnitude of what we get, this is the beginning of the alphabetic list of languages that are covered by OSCAR. There is a special multilingual corpus since the last version of OSCAR, and that is because we do document-level language identification. We are actually able to identify documents which contain sentences in multiple languages, and so the documents are dubbed multilingual, and we have a special corpus of such documents. And then you see that the sizes of the corpora are reasonably large. So 5 billion words in Czech, 1.6 billion words in Slovak, extract from the web. As I said, once we obtained our French version of OSCAR, we were able to train the first large-scale language model for a language other than English. The situation indeed in 2019 was the following. We had ELMO with the LNAI sharing a number of ELMO models for a number of languages, but the transformers had just arrived in the form of BERT, multilingual BERT, a Chinese BERT, actually published by the same authors. There was a German BERT as well. Quite quickly, Facebook published an alternative, actually simplified but optimized variant of BERT called Roberta. And this is exactly when we decided to train CamemBERT. So CamemBERT is freely available, and we had two scientific questions in mind when we trained the model. First of all, does a monolingual corpus language model perform better than a multilingual one, such as the multilingual BERT? And the second question was, how much data do we need, and how diverse should it be? It was then assumed that you needed at least 100 gigabytes of data to train a monolingual language model. Since then, of course, a number of other language models, including for French and obviously for Czech, have been published. Some of them are on the slide. So what we did in order to answer our scientific questions was to actually train a number of different language models. We varied the size of the corpora and the diversity of the corpora. So we used OSCAR, web-based, CCNet, another corpus, which is, you can reconstruct it freely, but it's not downloadable. It's done by Facebook, Meta. It's also Common Crawl based, and we compared it with the French Wikipedia, which we assumed was more homogeneous in terms of style, if not in terms of domain. And of course, we evaluated the model using techniques that François sketched earlier today, and on 4 downstream tasks: part-of-speech tagging, dependency parsing, because we have a long history with dependency parsing, as probably Jan knows, named entity recognition, and natural language inference. And the take-home messages of our experiments were actually surprising to us. We realized that 4 gigabytes of data is actually enough to train a good quality language model that performs at the state-of-the-art level for most tasks, maybe not natural language inference, which is more semantic, more abstract, and that seems to require more data. But 4 gigabytes of pre-training data is enough. We actually believe that 1 gigabyte of training data is enough, and this is because of more recent experiments we carried out on modern French, that is French from the 17th century, and medieval French. But in order for your corpus to be allowed to be that small in relative terms, your corpus needs to be diverse. So 4 gigabytes of Wikipedia data does not really work. But 4 gigabytes of web-based data, because it is diverse, is more informative, and as a result, performs very well, and indeed at the same level for most tasks as the full OSCAR for French, which at the time was 128 gigabytes, so much bigger. So these were 2 experiments that we did on for developing corpora and language models. But in fact, while doing this, while working on these things, we always kept in mind issues regarding the quality of what we were doing and biases introduced by our corpora in the language models. So first of all, we took part in an interesting experiment whereby a number of very large corpora, including OSCAR, some of them monolingual like OSCAR in the sense that covering a lot of languages, but with subcorpora that are all monolingual, and others which are parallel corpora. The experiment was to try and manually evaluate the quality of these corpora in terms of, do they contain non-linguistic content, how much content they include that is not correctly classified by language, and do they contain a lot of problematic data, such as pornographic content, offensive content, and so on and so forth. And so the manual evaluation was actually very instructive. The main outcomes are that languages for which there is less data suffer from lower quality as well. So if you have more data, it is more likely to be of good quality. If you have less data in your language, it's likely that the little data you have is actually of lower quality. We were surprised by the fact that in most of these corpora, the proportion of offensive and pornographic content was actually lower than we expected. This is not to say that it is not problematic, especially if you train generative language model on such corpora, but still that's an issue. And surprisingly, we realized that there was a problem with language codes. So basically, there is a stupid issue of standardization regarding language codes that affects the quality of some of the subcorpora. But more important issues with these language models, and they all come from the training data in which they are, on the data on which they are trained, are a number of biases. And of course, I'm not a specialist of biases per se, but we believe it's very important to actually realize that what we're doing when we train language models includes the creation of language models that contain biases. And there are a number of biases in our language models that I would like to sketch, especially this first category of biases, which I call, I'm not the one to call them like that, but which can be called representativity biases. So everything starts from the observation that the corpora on which we train our language models are a reflection of the people who actually produced the data, who wrote these texts that we use when we train our models. And this creates a lot of representativity biases, because basically, especially if your data is based on web content, people the people who write things on the internet are not necessarily, and indeed not at all, representative of the people in general. I think there is an example, I don't have the exact figures in mind, but I think that on Reddit, the vast majority of people who write things on Reddit are men who are aged 18 to 35, which is obviously not extraordinarily representative of the general population. Another obvious problem on which François has discussed already is that obviously in a multilingual corpus, not all languages will be represented with the same amount of data. And as I said before, one of the results of the manual evaluation that we did on Oscar and other Corpora is that languages that are less represented are represented with data of a lower quality. And another issue is that the most resourced languages, so basically English, some of the Western European languages, and maybe a few others, are on average not representative of what languages are around the world. The most resourced languages are mostly with a very strict word order, a very poor morphology, with respect to the majority of world languages. And this also, it creates some sort of abstract bias. And so we did not actually talk, François and I, before. So the next slides I will go very quickly because they overlap what he said. But basically, in the context of that big science project, in which we worked on preparing the training and indeed training the Bloom multilingual language model, the corpus that was actually developed looked like this. So this is basically the same. It's another graphical representation of something that François has already shown. But what I think is interesting is that when Bloom advocates that it covers 46 natural languages, they include these ones, but they include also these ones, right? And so, for instance, one of the languages that is officially covered by the Bloom model is represented by only 0.00002% of the training data. And I'm not sure that this is an acceptable statement to say that Bloom actually includes 46 natural languages when one of them is covered by such a small quantity of data. Maybe it is. Maybe that's enough because of language transfer. We will know that in the coming month. The evaluation of Bloom is still ongoing, but I think as of today, it is a question that is still to be answered. And by the way, there are Niger-Congo languages in Bloom, there are Indic languages in Bloom. I think that's great, but there are no Slavic languages. These are some of the decisions that have been taken for reasons that are beyond my power and understanding, indeed. So just coming back to this slide, removing the illustration and discussing another representativity bias. As François has briefly shown, our language models use what we called subword tokenization. So because we need a fixed size vocabulary, we tend to have a mechanism whereby we prepare the data by splitting rarer words into smaller units and keeping more frequent words as such in order to be able to keep a fixed size vocabulary. And the thing is, of course, most languages on the planet, and indeed virtually like most large languages, resource languages, use the Latin script, which means that some of these subwords, some of these words will be shared across languages, and they will reinforce their own predominance in the model. And that also creates a bias in favor of these languages. And we're working in my team with some of my students on the question of understanding how can we actually alleviate, at least in part, this issue by trying to to develop fairer ways of tokenizing multilingual content in order to partly alleviate that bias. I will skip this because this was discussed indirectly before, and I'm running out of time. I'd like to come back to these issues with biases quite quickly. So, as I said before when discussing these offensive contents in OSCAR and understanding whether we need to remove them or to tag them, I think that we must think of the downstream applications, and indeed, it is not the same if you work on analysis or generation. If you want to, for instance, automatically detect hate speech, you need hate speech in your training corpus. If you want to generate text and you don't want to generate hate speech, maybe you want to avoid hate speech in your training corpus in general. And in fact, this dichotomy of different attitudes that you can have in front of offensive content or undesirable content. It applies to the training corpora, but it also applies to the language models. You can try to minimize biases in the language models, whatever that means. You can also keep the language models as they are and try to post-edit or correct or filter out the unwanted content. And in fact, at a more abstract level, I'm wondering what it actually means to remove biases from corpora or language models. I mean, who are we to actually decide what a bias is? Trying to say that this type of bias should be removed is a way to say that once it's removed, the language model is objective, it has no biases. But this point of view is very subjective, and this objectivity that you are trying to superimpose to your language model is actually your own subjectivity, and it might be very unacceptable or completely different from what other people would consider as being an objective and de-biased language models. And this is, I think, an open question that is discussed in several papers, and in particular with Wasim et al. 2021. I think we should keep these things in mind when we work on these language models. So just to conclude, large text corpora and language models play key roles in NLP today, but they raise a number of challenges. I've very briefly discussed representativity, and I have not discussed representation biases, but they also come with computational cost, which actually means that not everyone can train these very large language models. Sometimes you need 500 people from 100 countries in a big science project to manage to train a model on a supercomputer. And of course, computational cost means energetic cost and environmental costs. And many people, including us, are working on data efficiency for that reason. And there is also all the challenges related to explainability, transparency, and trust in what language model produce, especially generative language models, which today, despite a lot of efforts and work, do not come with any guarantees whatsoever that what they produce is correct, valid, not offensive, and that is, I think, a lot of future research to be done. Thank you.